Hey everyone, and welcome. I'm Dr. Ed Pearson III, and I am absolutely thrilled to be guiding you through today's explainer. You've already done the heavy lifting of sourcing and vetting your dataset, but now we face the real test. Today we're focusing on how to turn that vetted dataset into defended evidence. We're talking about evidence that is so robust, so transparently prepared, that it can survive the toughest cross-examination from literally any reviewer. This is the exact moment your data stops being just a messy spreadsheet and becomes the undeniable foundation of your capstone project. Okay, let's dive into this. Think of your raw data as a star witness in a high-stakes trial. Right now, that witness might be a little confused, holding on to contradictions, maybe remembering things totally out of order. Before we can ever put them on the stand to testify about your root cause, we have to prep them. We've got to interrogate the data, clean up those inconsistencies, and ensure that what it's telling us is the absolute, unvarnished truth. Because a dataset doesn't just get a free pass into your capstone, right? It has to earn its place.
So here is our strict 4-step syllabus for today. We'll start with the systematic cleaning pipeline, move into exploratory data analysis, look at honest visualization design, and finally wrap up with audience-adapted communication. These are the 4 critical hurdles raw data has got to clear.
Starting right off with Step 1, the systematic cleaning pipeline.
Look, before we can run a single statistical test or build a single chart, we have to address the mess. And let's be real, every dataset inherits some kind of mess from the data collection process. So we start with raw data. That's the data exactly as it was collected, before any corrections or filtering. It's that exported CSV full of blank cells and random typos. But here's the catch. Every analytical tool we're going to use expects tidy data. Tidy data is perfectly structured. Each variable gets its own column, each observation gets its own row, and each single value sits neatly in one cell. Bridging that gap between raw and tidy, that is your first major hurdle.
To actually get to tidy data, you have to hunt down 4 specific culprits lurking in basically every raw data set. First up, missing values. Are you going to delete them, impute them, or flag them? Next, duplicates. These could be exact copies or fuzzy matches. Think J. Smith versus John Smith. Third, we've got inconsistent formats, like mismatching dates or units. And finally, outliers. Now, I have an absolute rule for you here. Never ever delete an outlier without investigating it first. I mean, a 200-year-old resident is clearly a data entry error unless someone actually found the fountain of youth. But a massively high housing cost? That might not be an error at all. That extreme value could actually be the real story your capstone needs to tell.
And this brilliantly illustrates what happens when we apply this to a real-world mess. Take our running capstone example of the rural broadband gap. In the raw export, we had exactly 1,204 rows, 96 blank costs, 31 duplicate submissions, and a wildly impossible 412-person household. I mean, unless they're living in a sports stadium, that is a mistake. But after our systematic clean, we removed the 31 duplicates by respondent ID, we flagged the 96 missing costs because simply guessing and imputing an 8% gap is just too risky. And we investigated that 412-person household, contacted the source, and corrected it to a 4. That is what rigorous prep actually looks like.
But listen, none of that cleaning matters if you don't follow the golden rule. If it isn't in the cleaning log, it absolutely cannot be trusted. Reproducibility and accuracy are just paramount here. If you quietly impute a mean into a field that's 40% missing, you are literally manufacturing a trend that was never in your data to begin with. Every single cleaning decision has got to be a documented choice, not some silent behind-the-scenes fix. Your cleaning log is your proof that your data is defensible.
Moving on to Section 2, Exploratory Data Analysis, or EDA.
So, now that your data is relentlessly clean and tidy, it's time to step back and let it speak for itself. We want to surface patterns tied directly to your root cause. To do that, we use the descriptive toolkit. We look at central tendency to find the typical value. We look at spread to see how much things vary. Because honestly, sometimes a high spread, like wildly uneven internet service across a community, is the actual finding, not just statistical noise. And we check the distribution shape. Summarizing data carefully prevents us from being quietly misled. For example, if you're dealing with extreme income or housing data, the median beats the mean every single time. Reporting a skewed distribution with only a mean is a surefire way to accidentally misrepresent the reality on the ground.
So the crucial point here is this absolute guardrail. Correlation is not causation. I literally cannot emphasize this enough. If you find that tracts with lower broadband access also have lower test scores, congratulations, you've found a correlation. You have not proven that lack of broadband causes lower test scores. Overclaiming causation from a simple correlation, that'll get your evidence thrown right out of court by any technical reviewer. A confirmed correlation earns further investigation. It does not automatically earn a causal claim.
Let's look at EDA in action with our broadband example. Through a grouped comparison, we see connection rates vary wildly, from 41% all the way to 89% across different tracts. Analyzing the trend over time, we notice the lowest tract only improved by 2 points compared to a 14-point county average. And in our correlation check, we found a negative correlation with distance from a provider hub. This process proves how proper scoping finds the actual tangible mechanism that we can go test in our capstone prototype.
Which brings us to step 3, honest visualization design. All right, so we've got our clean data and we've got our patterns. But finding the truth in your dataset absolutely does not matter if you distort that truth when you finally show it to the jury. Visualization is a strict discipline of honesty. You've got to follow a few rules. Always start your axes at 0. A truncated y-axis can turn a tiny 2-point difference into a dramatic, terrifying cliff. That is manipulation, not analysis. Second, cut the chart junk. I passionately condemn misleading 3D charts, redundant grid lines, and useless decorative icons. They add noise, not information. Label your data directly so a reader doesn't have to endlessly hunt through a tiny legend. And finally, always match the chart type to the specific question you're asking.
Now, what's really interesting here is the clarity. Imagine a flat 2D zero-base bar chart with direct labels. No 3D distortion. No chopped-off y-axis starting at 40% just to make a gap look triple its actual size. By sticking to one neutral color and highlighting exactly what matters, the true 41% to 89% broadband gap reveals itself instantly and accurately at a single glance. The numbers didn't change, our commitment to revealing the truth did.
Moving into our final phase, audience-adapted communication.
Okay, you have your defended insight and you have your honest chart. Now, you've got to deliver this truth in 2 completely different languages without ever diluting the facts. You see, you're speaking to 2 distinct groups. Technical reviewers want the method. They want the sample size, standard deviations, and named statistical tests. They need to know exactly what you did with missing data. But your community stakeholders, they want the meaning. They expect plain language and relatable points of comparison. Notice how the underlying truth, the sample, the correlation, the honesty, that stays exactly the same in both versions. Adapting your delivery doesn't mean dumbing it down. It simply means changing the vocabulary to serve the audience.
Let's see how this builds into a foolproof 4-step narrative structure that works perfectly for either audience. Step 1. Lead with the insight. State your finding in one clear sentence before showing any method. Step 2. Give context. Define the population, the place, and the time. Step 3. Show the evidence. Present that one honest visualization that best supports your point. And step 4. Say the so what. Connect this finding right back to your root cause and explain exactly what it means for your upcoming prototype.
And that brings us to the final verdict. We have reached the climax of our process here. You've cleaned the mess, explored the patterns, designed honest visuals, and tailored your narrative. Before you submit your capstone analysis package, you must pass this final defense checklist. Have you documented every data quality issue? Is every single cleaning decision logged with a clear reason? Are your descriptive stats tied directly to your root cause? Are your correlations labeled strictly as correlations without jumping to causal claims? Do your visualizations use honest axes and minimal clutter? And finally, do you have both a technical and stakeholder version of your key finding? Checking off all these boxes is the necessary bridge you have to cross before we move on to Module 7, where we start designing and building AI-driven solutions. I'll leave you with this thought. As you review your work, take a hard look at your evidence and ask yourself one final critical question. Does your cleaned, analyzed, and visualized data actually tell the dataset's true story? Or did you just force the numbers to fit a conclusion you had already decided on before you even began? The rigorous defensibility of your capstone rests entirely on your honest answer. Thank you so much for your focus today, and I look forward to seeing your defended evidence.